So the first thing we're going to want to do is hop into our remote Linux box and fire up Emacs. Let's open our program here, and just to show you what's going on, let's show you this source code. So this is your standard CMake project. Its layout has a source. Inside of here we have our main, and we have a math-utils library. And of course in the include we have the header for the math-utils. Alright, so first thing we're going to do is just look at some IntelliSense-like features. Note that in our math-utils header that we have this simple demo, and it has a bunch of functions here that we're going to want to run. So we'll start to type. It recognizes that demo is in scope and offers us these functions. We'll choose add. Now before I try to use this function, I like to read the documentation. So let's see what this is about. It says, here's your function, here's what provides it. It takes a vector of int as its parameter and returns along with a description of what the function does. This is important because obviously we want to run the right function. Alright, so we're going to use it now, and as I start to type the variable name for numbers, it recognizes that and says, here you go. Now, I don't really like the name add here. I want to change it, so let's refactor it. Here it's offering me a way to rename it, so let's call it sum. It sees, first of all the project or the files in the project that it wants to modify. I'll say, yep, go ahead and do the work. And we'll go ahead and just rebuild it so that our symbols come into alignment. Now, let's pretend that we're just running into this for the first time, and we want to know, well, where all is this function used in the system? So that's easy to do. We can just bring up a query and ask it. And here we see that twice in this file it's used. Here it is in the header where it's defined. And yeah, there's the implementation. So we can jump to the implementation here, have a look at it and go, yeah, that looks about like what we want. So we can pop right back out. And yeah, that's probably good for that part of it. So let's just do this. We'll go down here and let's add a breakpoint. We'll do some debugging now. And let's put a breakpoint up here on line 13 as well. Alright, we'll crank up our debugger. And immediately we've hit our first breakpoint. So take a look at what we've got over here in the info. We have our variables. We have our stack frames. This is very important because it tells us exactly where we're at in the program with our cursor. And our list of breakpoints and threads, and of course our REPL down here. So take note of the fact that numbers has been defined and initialized here. It's of size 7. And total is also in scope, but it hasn't been initialized yet. It's got this big C++ value that it hasn't, because it hasn't been assigned yet. So we'll take a step. And if you look here now, it has been defined. Right? We summed the numbers up and it was assigned. So we're going to print this now. So let's see how that looks down here in the REPL. Yep. And now we'll exercise our max element. And again, we're just going to print it and see what it does. And it says that our max is 9. And when we look at our numbers up here, indeed, that is true. So we'll just hit continue now, and we've started into our loop here. We can see that now we have I in scope, and it's been initialized to 2. Let's step inside of this function and see what's going on. So I is 2, and it immediately discovers that, okay, I is prime. So it's going to do that. Now we know 3 is prime too, so I'm just going to continue there. But now I is assigned to 4, right? So when we step inside, we start to step through this and we see, yep, no, it's not prime, and that's exactly what we expect. I'm going to step in here one more time, and we've seen this function a few times, and it's really not worth running the whole thing. So let's just step out And boom, there we are, right back where we expect to be. So, stepping over, stepping in, stepping out, these are essential features anytime you're debugging and you want to just kind of move through the code at your own pace. Now, every time it runs, it's hitting our breakpoint here. And if we have a massive list of values here, we're typically only interested in some subset of them. And this is why we can put conditional breakpoints into place. And you can see down here it's offering us to do that. So let's say we only want to break when I is, we'll say 15. Okay, so it tags this line for us. I is currently 6, so I'm just going to continue. And it's already hit the breakpoint again, and I is now 15. So it just skipped all of those other values. That's pretty cool. But what if we want to initialize or we want to change the value of I to something else, right? So first, let me change our breakpoint here. We'll change it to 19. Okay, and so we're still sitting here. I is 15. I'm gonna change it now. We're gonna basically mutate I, and it's 15. Let's set it to 17. We'll just skip 2 spins. So note that it has been skipped, or sorry, that it has set I to 17, but our cursor never moved. And so, if we start stepping, we step through, I is now 19. And so we're able to change the variables and their values in the system while it's live and debugging. This is a super powerful feature. One more thing I want to show you about this is that we can just run ad hoc functions, right? We can ask it questions, like we can see here that we're going to spin 20 times, but let's ask it, hey, is 100 prime? And the answer is no. Okay, how about 101? Are you prime? Indeed, it is prime. So you can see that you have the ability to just play with your code. You can run your functions ad hoc inside of the system, and that's a very powerful capability. I'm going to add one more function here, or one more breakpoint, and it's here on this factorial line. So I'm going to continue. We've hit it, and I want you to watch what happens here. Let me drag this out a little bit so you can have some room to see what's going on. Okay, so we're currently on line 24 in our main. All right, I'm going to step in to this factorial function so you can see that it's added a stack frame, and it says now we're in math-utils on line 24. That is indeed the case. Okay, so we're going to start stepping. Okay, and notice that I think we stepped right over it. I think we stepped right over it. Yeah, we did. Okay, we get another chance here. Okay, so I'm going to step in, and we're going to step down here. We're going to step in again, and look what it did. We recursively called ourselves with n-1, and so now we've added another stack frame for the same function another time. Let's keep doing it. Oh, looks like we're only going to run it twice this time. Okay. And then it unwinds, right? And so this ability to watch where you are, what functions and what lines within the various files that we're calling is incredibly powerful. You don't have to just blindside this stuff. You can really have all of the features that you typically have in a heavy local IDE right here. We're just in a terminal, and we've never had to do anything other than just open our project and go to town. So when we're done here, we can shut down the debugger, exit our program, and pop right back out where we were. That's the whole workflow. We got completion, navigation, refactoring, debugging without ever leaving the terminal. The point isn't that Emacs is old school. It's that a terminal, SSH, and Emacs are genuinely enough. No heavy GUI, no subscription, no vendor lock-in, just an Emacs config file that you own. It's free and it's on GitHub. I'll put the link in the description. If you want to run it yourself, go for it.